So our next presenter is Arend Wieringa from Bestech. He is the head of products and engineering, and his topic is integrating IoT and smart sensor networks in structural health monitoring, along with a case study.
G'day everyone, nice to be here, nice to see some familiar faces. So I hope you're having a good conference and enjoying Melbourne for some of you who are down here. We'd like to introduce Bestech. Hopefully most of you know us. We do sensors and teaching equipment. We've founded 2002, so we've done over 20 years now. We've just had a recent change in ownership, so we're now funded by a private equity group and we're growing quite fast now. So we've just got a new business in Perth. We've got our feet on the ground over in WA, so offices right around the country. And we've got some local manufacturing capabilities in Melbourne. We manufacture some teaching equipment for the electrotechnology industry. We manage package leak testing for food products, and we've just released a couple of products for the plasterboard industry where we're measuring some dimensions online. All our team of factory engineers trained, so we've got product specialists on the ground, and you can see the sort of three areas now. We've got sensors, instrumentation, data acquisition, technical teaching equipment, and enclosures and power surge protection. So we really hope to be part of your journey in terms of what you're doing in terms of measurements. We're at the start where we advise what we can do, what products are on the market. We help you specify what you need. We're looking at the design and development stage. If you need testing and delivery for some of these things, that's important. Sometimes wireless communication may not work very well. And then we're there for the backup and support afterwards. So you can see here some of the brands that we represent from around the world. So we really pride ourselves on good quality products from around the world with the local support from sales engineers and application engineers on the ground. So we work with a lot of universities and companies right around Australia. So there's a few there. Hopefully you can see your name there, or I hope we haven't missed any, around Australia and New Zealand. So IoT and structural health monitoring, utilising the wireless technologies, you've got quite a few benefits for that, obviously. So integrating large number of sensors is a possibility, gives you more comprehensive ability to get over large structures without certain cabling required. You've got ease of installation, and then you've got leveraging large sets of data for you to analyse. So there's a couple of structures that we can go through. Not everyone needs to be wireless. Sometimes you want wired systems, depending on what the application is and what speed you want to monitor the data. So there's one here where we've got nodes. This is a vibrating wire sensor system that goes back up wirelessly through the mobile phone network. And you've got nodes that can be expanded in and get quite a large area there. There's another one that Utsav, my colleagues, got out the front there, where we've got 2.4 gigahertz wireless network. There's a gateway in the middle here, and then we've got various sensors that can be put around that can be connected to a whole range of different sensors. So we've got strain gauges, load cells, accelerometers, displacement sensors that can be integrated into this system. And then that data can go back onto your desktop and you can collect it. There's another one here from a company called IMC, which gives you a lot of strong onboard processing. So this can take measurements at 48 kilohertz, do onboard processing and just send the data back you need, so you don't have to store it on hard drives and come and collect the data. It's got a post-trigger and a pre-trigger, so if you're looking at vehicles running over bridges like in a previous presentation, you can get the data really fast and then process it so you don't have to have that much data. In certain applications where you've got a long distance between your data logger, you can also use fibre optic sensors. So the data acquisition system can be 40 kilometres away from your sensors without any loss of signal. So that can be very interesting and very cost effective for cabling on these large installations that maybe the radio signals aren't fantastic in, like tunnels. Just a bit of an idea on some of the sensors that you may want to use. We've got the wireless accelerometers, but also accelerometers that go down to a DC response, so you can get almost tilt measurements from an accelerometer. You've got dynamic accelerometers here that really don't go below 10 hertz, so it really depends on what vibrations and what measurements that you're looking at as to what sensor you want to put with it. For displacement, you might all recognise like LVDTs, but there's a lot of strain gauge sensors that can fit into small areas that other ones haven't been able to in the past. And there's a new one we have in our range, which is a rubber sensor. So that's got, it measures displacement, but you can get off-center measurements quite easily. And then all these can be coupled up to a wireless network. Strain gauges, we've got the foil strain gauges, vibrating wire, embedded concrete gauges, and fibre optics here. And we'll keep you all informed. We've got it working with a new company that are doing DIC with cameras. So they've got some interesting projects where they're looking at bridges from a long distance away using telecentric lenses or telescopic lenses and looking at strain from, I think, up to 2 kilometres away. So we'll keep you posted on that when that happens. So no need to install sensors at all on the structure. We've got a bit of a case study here. One of our customers a few years ago wanted to measure the angle of gates in bridges, I think, floodgates. So one was to measure displacement, but we've used tilt sensors wirelessly here. There's some information there on how we power the sensors and how they worked, but the displacement or the tilt of the bridge was done by a tilt sensor. And they're installed now and they're still working. I kept it a bit short, so thanks very much.
Thanks, Arend. There's a lot of options there in terms of type of sensors and different use cases. Any questions for Arend?
Tony's back, by the way.
Thank you for the 25 years of great service. Do you have any ambition to compete with us, to be an integrator and be out there under bridges sticking stuff on?
No, I was just saying to your colleagues before, we want to keep us separate to the installation. We don't want to be competing with our customers, and where we can recommend them to do the installations, and we can be that sensor partner on what you need.
Thank you for your question. Thank you for your presentation. So I purchased some beam device, smart meters gateway some years ago. So compared with the traditional wireless sensors, so what's the main difference of this wireless IoT sensor? And for this one, what is the communication protocol between sensors and the gateway?
Yeah, we've got the 2.4 gigahertz with the BNAIR system. Some of these new wireless sensors that are coming out are a lot slower, and they're using things like LoRaWAN or NB-IoT. We haven't got too much in our range for those things, but they're longer transmission distances but slower data rates.
Thanks, Arend. Thanks for your presentation. Oh, there's one more.
So, Arend, bit of a bigger question. Given you're a supplier and you would like to see more uptake in SHM so that you can supply more and go live in your mansion, what role can you play, and what do you think we could do better to generate more uptake in SHM?
Yeah, that's a great question. We see so many projects from our suppliers where they're putting strain gauges on multitudes of bridges around the world, multitudes of dams, multitudes of buildings. Maybe we can hire someone with a really heavy truck to do a bridge collapse. That might help things, but we don't want anyone to get hurt. I think a big part of this is education, in terms of you've got these big bridges that people drive across every day. The cost of maintenance, the cost of uptake, and the safety of these bridges with more load and more traffic going over, that needs to be brought into the mainstream a little bit so people realise that it's not just something sitting there, someone's looking after it. And then with that sort of concern happening, then hopefully that funding will come with it.
Yeah, clearly a lot of things happening under the radar as well that we're not fully across. So thank you for your presentation.
Thank you everyone.